Hi guys, and welcome to another video. This video in particular is a part of a series. It's the last video of the series regarding sine and cosine rule. So if you're interested in any of those other videos, feel free to check them out now. But this video is again, like I mentioned, about worded questions for sine and cosine rule. The first question I'm going to go through is quite straightforward. It's a bit easier to understand, and then the next one's going to be a bit more difficult, a bit more wordy and stuff like that. Most of these questions you might have seen in this past series actually come from the Sadler textbook. This is a part of this Math Methods unit in Western Australia. So if you are curious about any of that, those are all from the Sadler textbook there. But if that doesn't matter to you, that's okay. So what I'm going to do now is I'm going to go through this question and we're going to read through it. We're going to highlight a few different things. We're going to go through it nice and simple. All right. So a triangle has sides of lengths 15.3, 12.5, and 16.7 centimeters. Find the size of the smallest angle, giving your answer to the nearest degree. Okay, so this is quite straightforward. So you're given three side lengths, so 15.3, 12.5, and 16.7. And we've also need to find the smallest angle, and we need to round it to the nearest degree as well. Okay, so first thing I'm going to do is I'm going to figure out, am I going to use the sine and cosine rule? Because they haven't specifically told us that it's going to be a right angle triangle. So we are assuming in this case that it has to be using sine or cosine rule. Okay, so also because these aren't actually very nice numbers to give us a right angle triangle. So I'm going to draw a quick diagram here, very, very rough. And I'm going to just quickly label some of these sides here. Okay, it doesn't matter how you do it, doesn't matter what size you draw on, it's just a rough sketch. So what's important is that when it talks about the smallest angle, it just means that it's the angle opposite the smallest side. And that same goes for the largest angle. So the largest angle is opposite the largest side. So realistically, we're trying to find this one. This is our theta or our A or whatever, that kind of thing. So that's what we're going to do. We also know that we're going to use the cosine rule, and the reason why I can say that is because I can see very clearly I don't have any pairs of sides and angles that can help me. I don't know any angles, so that sine rule is going to be quite useless to me. And also because the cosine rule is really good for anytime you need to find it, you've got one angle and then three sides. So I'm going to write down my cosine rule now. So a squared equals b squared plus c squared, take 2bc cosine a. And what's really important is that you might notice that I actually need to find an angle. So I need to find A. So let's see if we can rearrange this. One, if you haven't seen that video about the cosine rule, I actually go through this a bit more in depth. But so let's rearrange that now. I'm just going to rearrange it in terms of cosine. Oops. Okay, so this is the rearranged version of it. So if you are kind of like, whoa, where did you get that? That's crazy. That cosine video is actually going to help you out. So from this equation, I'm actually going to now substitute what I know. So I'm going to label my sides first. This is my A. This is the angle that I don't know. This is this. I'm going to label this lowercase a because it's my opposite. Again, the pairs, they got to be opposite each other. I'm going to have B and C. So it doesn't really matter the angles in this case, but there we go. So let's substitute it in now. So cosine A is equal to 16.7 squared plus 15.3 squared, take 12.5 squared, divided by 2 times B, which is 16.7, times by C, 15.3. All right, so I'm going to put in my calculator just really quickly now. So 15.3 squared, take 12.5 squared, divided by 2 times 16.7 times 15.3. There we go. Let's see if I can do it. I think I might have written it in wrong. Let's try again. So yeah, this is a good time for you to be writing it in too. Alright, so I've gotten something 0.698 blah blah blah. So it's meant to be a small number. So don't be surprised by that because we actually still have to find the inverse of this. So if you're a bit worried about that, don't be. All that is that you have to find the inverse. So it's going to be quite a small number. Okay. So what I'm going to do now is I'm going to find A. It's going to be the inverse of that. So I'm going to keep that number in my calculator. All I'm going to do is going to shift cosine. So it gives me that cosine -1. Put the answer in. I'm going to get an angle of 45.727, blah, blah, blah. And because it specifically asked me to round to the nearest degree, I'm just going to round that up to 46 degrees. All right, easy peasy. All right, I'm going to just highlight my answer so that my teacher can clearly see it, or whoever's marking it. This is really useful and a really good habit to get into when you're just studying and stuff like that. So that's what I'm going to do now. So just highlight my answer. All right, this is the one that I said that was a bit wordy. So let's go read through it together very slowly, see if we can figure it out. So, a tower stands vertically at the base of a hill that inclines upwards at an angle of 30 degrees to the horizontal. From a point 25 meters from the base of the tower and directly up the hill, this tower subtends an angle of 52 degrees. Find the height of the tower, giving your answer correct to the nearest meter. There is a lot to actually kind of break down here. So let's do that now. So I'm going to get my highlighter out. So, tower stands vertically at the base of a hill and inclines upwards at an angle of 30 degrees to the horizontal. So at the same time, I'm going to try draw a diagram. So let's say this is my tower. Very fancy. Okay, so is at the base of a hill that inclines upwards at an angle of 30 degrees to the horizontal. So the horizontal is just straight across, and this hill is making an angle of 30 degrees. All right. So from a point 25 meters from the base of the tower and directly up the hill. That means if you walked up the hill, this section here, if you walked up it for 25 meters, yeah, then the tower subtends an angle of 52 degrees. So then you're kind of like, what does that mean? What is that? So subtends I like to describe as kind of like a side that closes up a shape. So because we need to find the tower height, so we know that this side is quite important to us. And when I think of subtends, I kind of think of it as like it closes up the shape, brings it together. That's not the scientific term, obviously, but that's how I like to think of it because it's the best way for me to remember it. So subtends, it kind of like closes up the shape. So that's saying that is making another side here, and it makes an angle of 52 degrees. Okay. So now we need to find the height of the tower, giving your answer corrected to the nearest meter. So you're trying to find this side. All right. So you might be like, well, okay, how am I meant to know if I need to use the sine or cosine rule or whatever rules? And remember that these worded questions always reflect back to your prior knowledge. So what do you know about triangles? Well, I know triangles have to add up to 180 degrees. Okay, so it must add up to 180. I've got one angle, I've got one side. I can't use either at the moment. Please help. We can do this. All right, so what I'm going to do is I'm going to actually figure out this angle here. So when in doubt, try to find other angles and sides. I've been given this 30 for a reason. Like I can't be just given information and they're useless. Okay, so here is going to be 30 degrees because this is horizontal. So this is the tower, this is the horizontal. It makes a 90-degree angle. So this here must be 60 degrees because 60 plus 30 makes 90 degrees. So that way it's completely perpendicular from the tower to the floor. Because I know that now, I could be like, well, I can find out what this angle is. So I can do 180, take away 60, take away 52, right? So 180, take 60, take 52, that gives me 68 degrees. Okay, so that looks good. That looks a bit better. I've got some more angles now. I've still got only one side. I do need to figure out another side. So I'm going to quickly redraw this a bit bigger, just so you can see what's happening. So I know this is 60. This is 68. This one here is 52. I know this is 25 and I need to know this. All right. So let's see if we can label our sides and angles. So this is my unknown. I like to make my unknown like the subject of the equation or the first bit. So I'm going to make this A. I'm going to make this B. And then C. So you can see I've actually got a pair here. So I've got this side here with this angle. I've also got this angle to this side, and I've also got this angle to this side. So here we go. We've got some pairs, and which rule is best for pairs is the sine rule. So I'm going to write down my sine rule here. So it's going to be A over sine A is equal to B over sine B. So what's important is that you can see I automatically knew that I was going to use this form rather than this form. because I want the subject, I want it easiest to have my unknown on the top, right? I don't want to have this and then substitute it in and rearrange it like crazy. I would like this one because this one I've already got the subject that I want on top. Less rearranging, super easy. So let's do it. Okay, so I'm going to ignore this for now. Let's just substitute what I know. So x over sine 52 is equal to b 25 meters divided by 68. I'm just going to multiply both sides by sine 52. Oops, I meant to put a sign there. Sine 52. I'm going to find that now, so I'm going to put into my calculator. There we go. My answer is about 21.247. And the question specifically asked me to round to the nearest meter. So the nearest meter to that is just going to be about 21 meters. There you go. Double underline your answer, highlight it, and there we go. And that's the last video of my series. I hope that this really helped you out, and I hopefully broke it down as much as I could. So yeah, thank you for watching. Please subscribe if you haven't already. And yeah, thanks for watching. Bye.